Hello, this is Chapter 19, Protecting Your Network. This chapter has a lot of definitions in it, and reads a lot like a glossary. So read the glossary in the back of the book, be familiar with these terms. This chapter has a lot of glossary type terms in it. So a threat is any form of potential attack against your network. So what are some of the common attacks? Spoofing. This is where a device is configured so it mimics or looks like something else. Common spoofed attacks are spoofed IP addresses and MAC addresses, spoofed email addresses, web addresses, usernames, and DNS cache poisoning. To get around DNS cache poisoning, to help protect against that, you can use DNS Security Extension or DNSSEC. Packet protocol abuse. This is where an attacker uses a protocol in a way it's not meant to be. Zero-day attacks. This is an attack that's new and takes advantage of a previously unknown vulnerability. And ARP cache poisoning. This is an attack on a computer's ARP cache. In this particular attack, a malicious device responds to an ARP request from the workstation, and it becomes that workstation's default router. This is a typical man-in-the-middle attack, or one of a type of man-in-the-middle attack. The defense for the ARP cache poisoning is the dynamic ARP inspection or DHCP snooping. Denial of service attacks occur when someone attempts to take a server offline. This might be a prelude to another type of attack. In one scenario, an attacker attempts to overwhelm the server's CPU, preventing the server from responding. An amplification attack is one such DOS attack, or denial of service attack. A distributed denial of service attack is when an attacker uses an army of computers, thousands of computers, called bots. The botnet, as it's called, is controlled by a single server or a single computer, and all these thousands of devices will actually attack a server and take it offline. A reflection or reflective DDoS attack is one type of attack that uses this botnet. A deauthentication attack is a wireless attack. This is where wireless clients are kicked off the network. This is done using either a rogue access point or a computer configured to look like an access point. A man-in-the-middle attack is where communications are tapped or rerouted through a malicious device, and the intent here is to listen to traffic and grab information such as username, passwords, credit card numbers, and other sensitive information. A session hijacking is similar to a man-in-the-middle. In this case, the bad guy intercepts the computer session to get authentication information. They're just really trying to just intercept that authentication. A brute force attack is for computers is used to guess all combinations of usernames and passwords. Another type of brute force attack is when a computer will scan a network for looking for all computers and all open ports on the network. Physical attacks are when the malicious actor, bad guy, gets physical access to the network hardware. Once they have physical access, that person can damage a server, network device, unplug a device, or perform other actions. You can try deploying fault-tolerant systems, high-available systems such as clusters, and each system should require its own login at the console. Just to keep people out of the consoles by walking up and just grabbing a keyboard and a mouse and performing actions on the terminal. Insider threats. An insider threat can be a malicious employee or an employee who just doesn't know any better. There are two types of users: a trusted user. These are users who have valid credentials to be on the network. And you got an untrusted user who don't have any rights on the network. A malicious user is staff who is intentionally attempting to access, steal, or damage computing resources. Remember, not all insider attacks are malicious. Sometimes the people who just don't know any better. They click on every email that comes across, and some of those emails are malicious. They just don't know. One of the techniques employed by a malicious user internally was called VLAN hopping. This is where a user sends command to a switch in an attempt to change their VLAN. Malware is any program, macro, or script that performs an unwanted action. Types of malware include crypto malware or ransomware. This type of attack uses encryption to prevent access to data and files. When the malware asks for payment to decrypt the files, it's called ransomware. A virus is not a standalone program. It needs a host program to spread or replicate. When a virus is active or it activates, it performs its unwanted action. Conversely, a worm is a self-replicating application that uses a network to replicate. A worm does not need another program to spread, where a virus actually has to attach itself to a known good program. Macro-enabled malware is a type of virus that uses macros to replicate. These macros can be embedded in any application that uses macros, such as Word, Excel, and PowerPoint. Just if the application has the capability of using a macro virus can be written. Logic bombs. This is a code that can execute when certain conditions are met. A certain time of day, a particular date, or when a particular file is created. A Trojan horse is an application that looks like one type of software. It could masquerade as a browser, your new latest, greatest app, or a word processor, but it's programmed to perform an unwanted action, such as steal data, encrypt files, or delete data. Got to watch out for Trojan horses. They're real common. They're becoming more common on mobile apps. You'll find a lot of mobile apps in an app store that are malicious by nature. A rootkit is a very low-level application that hides in the operating system boot sector or in firmware. It's very difficult to find, and most antivirus software can't detect this type of malware. Adware and spyware. This is not necessarily malicious software, but definitely software we don't want. Adware monitors your activity on a computer, finds out what websites you're going to, and displays pop-up ads related to activity it sees. Spyware is a program that sends information about your internet activity to a computer or server on the internet. Again, they're just someone trying to track you and figure out what you're doing. Social engineering is the attempt to manipulate an employee to gain access to a network. A real common type of social engineering is phishing. This is where a victim receives an email that looks like it's from a trusted source, a bank, some web retailer, your boss. The email tries to convince the victim to click on a link that may contain malware or query for account credentials. The malware may send you to a website. Then that website might look legitimate, but when credentials are entered, these are sent to the criminal. A physical intrusion is a physical intrusion into an actual building. And this is where someone pretends to be from a trusted source. They say they're from a telephone company, and someone's called in an order to check a telephone line, or they say they're from a trusted vendor, and that they have some reason to be in the building. They do this to gain access to the building. Some of our common vulnerabilities. So first, a vulnerability is a potential weakness in infrastructure that someone attempts to exploit. One common vulnerability is running unnecessary software. when you buy a computer and you boot it up for the first time, most of the configurations of the operating systems have a lot of applications and services that aren't really necessary for you to run. These unnecessary services might contain vulnerabilities that can be used to gain access to the computer system. So it's best to turn off all unnecessary services. Unpatched legacy systems. We talked about this a few chapters back. Companies release patches to remove vulnerabilities in software. So if you have an unpatched system, or if you have a system that's really old that is no longer supported, where patches aren't released, vulnerabilities may exist that can be exploited. So companies should have a process to retire systems when software is no longer supported. Again, we're just trying to avoid future vulnerabilities. And a company should have a process to test and deploy software patches. Unencrypted channels are when we use software that transmits data using unsecure protocols. So we should try using protocols like HTTPS or TLS, SSH, VPNs, WPA2 for wireless, SNMP version 3, that's the Simple Network Management Protocol version 3, MS-CHAP version 2, and AES. And we're going to try to avoid protocols like HTTP, Telnet, SNMP version 1 or version 2, PAP, DES and triple DES, WEP, or WPA. When it comes to hardening your network, don't forget your physical access. So, it's very important to keep a building physically secure. So, install cameras, install locks on doors especially to doors where you store your servers and wiring closets for routers and switches. Hire security guards, deploy man traps. For your network security, consider multi-factor authentication, network access control, radius servers, and guest wireless networks. This way you keep your guest users off of your corporate network and give them access just to the internet. Device security includes patching the operating system and software, so again, applying patches. Using the least privilege concept when providing access to data. Least privilege is the concept where we grant rights to individuals so they can do their job but no more. Let's deploy our anti-malware, antivirus software. Deploy your host intrusion detection and intrusion prevention systems, and deploy host-based firewalls. Host-based firewalls now are built into, say, the Windows operating systems. Your network edge is the area between your network and the internet or other networks. So we want to deploy network firewalls. And rather than using the older style firewalls, consider using next-gen firewalls or with unified threat machines. These devices have built-in intrusion detection and prevention systems, sandboxes, and other security items that make them much more difficult to break through than a standard firewall. Be sure to install your network intrusion detection and prevention systems. Configure access control lists where you limit access from the internet or from DMZ or from other networks to only very specific IP addresses on very specific ports. Use VPNs for connections from other locations. Create a DMZ, a demilitarized zone, for your internet servers, such as your websites and external email systems. And consider using honeypots. That's it for Chapter 19. Again, just a lot of definitions out there, not a whole lot of technical content. We'll have Chapter 20 following shortly.